present plenary number 4, titled, yes, there is, Data Envelopment Analysis with Undesirable Inputs and Outputs. At this time, I'm pleased to introduce Dr. Charles Vincent. I'm going to read, please be patient with me. I'll try to be as careful as I can. Professor Charles Vincent is currently with Centrum Católica as a full professor and principal investigator in the area of operations, logistics and technology. He's a product of National Institute of Technology, Warangal, India, and National University of Singapore. He has put over 13 years of teaching and research experience in operation research, marketing research, business, statistics, and applied mathematics and computer science subjects. His field of research specialization includes marketing research, operation research, multivariate statistical techniques, Six Sigma, and Kanban techniques. He published over 45 research papers in both national and international reference journals and proceedings. He has presented over 48 research papers at national and international conferences and supervised many MBA, MCA, and MPhil students, and is currently guiding many PhD scholars. Some of his contributions can be seen in leading journals like Annals of Operation Research, European Journal of Operational Research, Asia Pacific Journal of Operational Research, Omega, the International Journal of Management Science, South African Journal of Science, Stochastic Analysis and Application International Journals of Operational Research, and International Journal of Quality and Reliability Management. He has won the Best Research Paper Award in 2006 in Finance from the Center of Financial Excellence, KLS, IMER, in Belgium, India. He has written the Indian version of the book titled Quantitative Analysis for Management, Person Prentice Hall. He is serving as a referee in the National and International Journals of RPT. He renders consultancy services to various renowned industries, as well as organized an ample number of management development programs and workshops on advanced data analysis using SPSS, the Scramble and SysTat for corporate and academia. Hopefully I did good. Please be kind to give a very good welcome to Dr. Charles Vincent.
Good evening to one and all. Am I audible? Yes? I thought of not to stay here on the stage. Maybe I move. Well, today we're going to discuss something about data envelopment analysis models with undesirable inputs and outputs. Before start my lecture, let me know that how many of you are aware of data envelopment analysis as such? Anyone? Yeah? Yeah, one professor will say yeah. 1, 2. So let's make it much interactive, though it is plenary. Yeah? Okay, I assume that 50% of people are aware of what is known as data envelopment analysis, right? If suppose if at all we are the people or student who is not aware of what is data envelopment analysis, let me put it in very easy terms with a small example. Let's say that 4 of our students wants to run for a while, and we decided to provide them a Coca-Cola bottles, right? A PET bottle, Coca-Cola bottle. Let's say something like this, a PET bottle. And every student started taking some level of Coca-Cola and started running. say they achieved a certain level. Let's say that a person who drank half bottle of this Coca-Cola ran almost a kilometer. Okay? The other person who took full bottle of Coca-Cola ran again almost the same kilometer. Who is efficient now? Who is efficient? The person who consumed half a bottle of Coca-Cola, still he was in a position to reach 1 kilometer, right? So if that is the case, taking a less consumption and trying to give a maximum output may be considered to be more efficient than taking more input, for this example, a bottle of Coca-Cola, right, and going to achieve the same level. So what we say that try to minimize your intake, the input, try to maximize your output in such a personality can be considered to be more efficient. You get me? Am I okay? Am I reaching you? Yes? No? Okay. So this is what we say. When then come back to the data envelopment analysis, what it does is it tries to give some sort of methodology or model which allows you to identify such a efficiency information. Then to identify such an efficiency information, what we say is we refer a particular term called decision making units. We say decision making unit. In our example, recently what I said, the number of students. There are 5 students who run for this particular game, and you can say that 5 decision making units are there. If I want to compare the banking sector in Peru, the number of banks in the Peru is considered to be the decision making units. Suppose in Catholic University, if I am interested to compare the departments, the various departments, performance of various departments in the university, then I can consider each department as one decision making unit. You get me? Okay. So okay, to start with this, the next one is, so we need to give input as well as output, right? Okay. If at all you have a one input, one output setup, we don't need to go ahead with data envelopment analysis. But somehow we can manage with the basic economic theory. But what happens is, basic economics, even to fit with the regression model, we need to know what is the model is, right? Gauss function, we know what is the function it is, right? A simple linear regression, we know the function. If you don't have a functional form with us, then what we can say, we don't know what exactly the functional form of the data going to form. Then this data envelopment analysis will help you in that structure. We no need to assume any pre-functions for the model. Add on to which, and the data envelopment analysis is much more flexible to you. It is unit free. So you no need to worry about the unit information when you are giving. When the first input can be number of Coca-Cola bottle, second input can be the weight, the personality weight, the body mass you can give. Nothing going to affect. You get me? The totally 2 different unit or various inputs. So what we are going to do throughout this analysis here, we are going to get some sort of inputs which you should supposed to put it in the model, and we have the output set. So what we are going to identify, which particular unit is efficient. I mean that decision making unit. You get me? Yeah. Okay. And apart from that, still I have to supposed to complete. I said that undesirables. What is this undesirables? Whenever we give an input, we cannot always expect a good output. Maybe sometimes we also get some sort of a bad output too. You get me? So such a bad output or a bad input is considered to be undesirable. Suppose let's say that the industry trying to manufacture papers, right? The paper mill production is more. The more you produce a good quality papers, the industry need to function more, right? Suppose if it is getting function, let's say that one of the bad output for the industry is carbon dioxide, CO2. So what happens? We need to increase the good quality of papers, but as well as what one should supposed to know? We should supposed to reduce the level of emission of CO2. So that is considered to be bad output, right? The bad output, what we refer here is known as undesirable output. You get me? So that undesirable output, either you can view that as a CO2 or else the tax imposed on such a bad emission can be considered as an input. Right? So always what we try to do is, depends on the technology, but to start with, we start the input, minimization, output, maximization. Always, right? You always want to pay less money and take out the maximum, right? The maximum gain from that. Yes or no? We don't want to study at all, but still we are looking for a good marks in the examination. Obvious, right? Do we or not? Of course. We don't want to spend more time on books, but still we look for good grades in the examination. Yes or no? Yes. So we teach internet to you to use how to use the Google, how to use the things, but we also learn how to use Facebooks. Yes or no? Good output or bad output? Okay, let's not discuss about that. Did you get the point? So what I'm trying to say, so the data envelopment analysis which helps you to identify the efficient units, or what is the level of efficiency. Later stage, one can rank those efficiency to who is in first and who is in the last. Depends on the given input and the given output. Sometimes what happens is, the input may be undesirable or output may be undesirable. Whatever may be the undesirability, we are expected to reduce the undesirable information in the model. Get me? Is it clear? What is GA? Still confused. If anyone is confused, you can raise your hands. Is that okay? Shall I pass on to the next slide? Yes. Okay. To start with, data analysis has become a standard non-parametric approach to productivity analysis, especially to relative efficiency analysis of decision-making unit. Why it is relative? Because I want to find the efficiency of one person against among the other person, right? The first example, remember that. The student who ran for the race, who is first, who is next, or who is efficient decided by the other person who is running. You get me? So peer. Who is here? Peer. Okay, so that's why we call this as a peer analysis. What it makes, it is not only DEA helps us to identify who is efficient. No, that is one purpose of DA. What is the other purpose of the DA is the DMU who is inefficient, how we should make such an inefficient DMU to move to efficient. That is more important in the analysis. You get me? What I am trying to say? The person who got a first rank in the classroom, well said, good fellow, he got a first rank. The person or the student who is getting a poor mark in the classroom, a professor should make the student to go up to the first person level. That is more important. So how to make the person to move? In what direction? So the professor should suppose to give some sort of input to the students, right? Okay, spend more time in the library, read more books, read more journals, try to practice your mathematics, try to practice your language, right? These are the inputs. How are you going to give input? Very easy. Compare the other student. See the other student who studied well. How? She spent more time in the library. Most of the time she was reading journals. Right? Most of the time she was spending more time talking in English. See that girl? You should also do it. If you do it, you can also get a good rank. So what's happening? A person is, the girl is already efficient. The other student wants to become an efficient student. So compare it. The data envelopment analysis, in one such analysis, provides you to compare the decision-making units. And whatever the unit which is inefficient makes you go further to efficient. You get me? So when this analysis, most of the time we talk about more mathematics, but don't worry about mathematics. Mathematics is always simple. Simple? Yes or no? No? Yes? Simple or not simple? How many of you say mathematics is not simple? Tell me that. Anyone? Yes or no? Come on. So this side, all my students are sitting here, right? So here all professors knows everything now. Over this side. Now, is it tough? Tough? Más o menos. I think that because mathematics is more scared you, right? The notations are scared you. How many of you notations scare you is there for mathematics? What's that? statistics, that's much faster than mathematics. Right? Yes or no? So I asked one student actually in the class motivated me to slowly start the lecture, so it makes lively more to understand what exactly. A student was in statistics actually, right? Statistics program. They say that, hey, did you understand the Bernoulli distribution? Did you heard about Bernoulli distribution? How many of you heard of Bernoulli distribution? Can you give a live example for a Bernoulli distribution? Obviously, what happens in a live example? The professor teaches that, take a coin, right, toss it once, the outcome is either a tail or a head, right? Okay, depends, fix a probability for that, and that's called a Bernoulli distribution, right? So what is the functional form? He immediately writes that P of x equal to P power x q power 1 minus x. Come on, that is not very difficult actually. So the student said that you are teaching very tough, sir. I'll put you in the other way around. What? I just like this girl. Wow, is it true? I wrote a letter to her. I'm going to give it to her. Right? Whether she accepts or rejects. What it is? Again, Bernoulli distribution. Yes or no? Yes or no? Yes, it is Bernoulli, right? Because yes or no is only the binary information required. The binary information can be fixed to any criteria. So the story started like this. So what was the story? So given the letter, whether she accepts or not, I am under the condition of Bernoulli distribution, right? Then, now how to increase to binomial distribution? What does binomial distribution says? Immediately p power x, p of x is equal to what? And cx p power x q power n minus x, right? X takes the value from 0 to n. What it is? That is much more simple. Same letter, take photostat for 10 copies, right? Same letter, what you should do? Take a photostat, 10 copies. 10 girls are sitting, give to all the 10 girls. Wait for the answer. 4 girls said yes, 6 girls said no. Yeah, I am under the condition of what distribution? Binomial distribution, right? Yes or no? No? No, you didn't view the binomial distribution in this way. That's what you are not remembering the formula. Then goes to that. There are 30 girls who are sitting. Okay, so what don't you do? Started giving 30 photostat to all the girls. Only one girl accepted. I am under which situation? I am under Poisson distribution. E power minus lambda lambda power x by x factorial. Right? What is Poisson? When n is large, when the probability of acceptance is low, I am under Poisson distribution. So, among the 30 girls, only one girl said that yes. So, it means that I am under Poisson distribution where my sample is large, my probability of acceptance of the letter is low. Poisson distribution. Let's see that. What else? The other distribution. Let's play. Okay, I started going one by one. I have only one letter. I don't have a photostat machine with me. So I want to go one by one. First girl. Can you? No. Second girl. Can you? No. Like that, keep on go. Finally, after 10th girl accepted. See. What distribution I am in? I am under the geometric distribution. Unless until one success occurs, I keep on trying. You get me? Yes or no? So what did it say? Q power x into p. That's what the formula for the geometric distribution, right? So distributions are very simple. It means that mathematics is also simple. Just to view the mathematics in a different view, where you can remember the formulas. Yes or no? No? Okay, back to the theory. Since the introduction of first DEA, Professor Charles Cooper introduced this particular concept as a DEA in 1978. He coined the basic idea. But seriously, if you watch DEA, it's not very great. The engineering students or engineers are already aware of this concept. They refer this as some sort of a weighted average techniques. But later, this technique is slightly polished and entered into the picture. Then they started calling that as data envelopment analysis. When you want to do a data envelopment analysis, there are some building blocks out there. So we have to take care of the building blocks. So what we are trying to talk about the building blocks. The first one, what is that? What is a preference order? The second one is what is production possibility set? And another one is known as a performance measure. So everything is confusing, right? Let's not worry about those. Let's see that. The building blocks are saying that the good DEA models can be supported with what is performance. How are you going to measure the performance? Right? What is performance exactly? So there are points out there with this. They say that either K-cone is one performance, lexicographic, AB matrix, economic order. Okay. Forget about all the three which is only for the professor. Let's just talk about the economic order. Usually if two companies, which company is doing better, how do you assume it? The company which gets more profit is considered to be always efficient, right? Yes or no? A very basic idea. Very basic idea, right? The profit, how you define the profit? Revenue minus cost. And the same concept it works on. Nothing more than that here. Let me put the DEA in a very simple form. I'm not complicating you. If you want the real formulas and structures, refer my papers, which where you read, you can find only the complex structures inside. But here the presentation, I don't want to make any complex structure. Let me put everything in an easy form. The next one, when you say the production, they have a set model known as a production possibility set. What they say is, what you give as an input, what you take as an output. With that, can I form a production methodology, a production form? So that's what they refer basically known as a production possibility set. It has a basic properties. You need to remember the properties. So what are the basic properties? It is closed, no free lunch. I tell you what is the meaning of no free lunch. Free disposal, convex mean. And then, if you want to measure the performance, what we say that performance is measured usually through metric functions. They have a list of metric functions in the literature. One is called an additive metric function, ratio metric function, radial metric function, almost radial metric function, and then additive MF with lexicographic orders. So these are the mathematics. It's not very much about that, right? Let's see that. We'll take a problem and then we'll see how it's going to work. And what this building block is, this holds the main information in the theory. What we say that desirable input, it means that the good input, and then the desirable output. Good output. The other one is, we can play around the combination, right? Undesirable input, desirable output. Next one is desirable input, undesirable output. Then they say that, no, it can be much more complicated. How to complicate? Desirable and undesirable together, right? Desirable input, desirable, undesirable input. Desirable output, undesirable output. What do they call? They call this as a mixture, right? So they call mixed input, mixed output. And they went to the one more step level up. No, we should think on some different direction. They said, okay, desirable input, targeted output. I target like this. I want this as my efficient. This is my target. Then they started modeling with the targeted output. So these are all the basic models existing in the DEA. With that, lots of complication exists behind. You get me? So what always we are trying to say, it's very simple. What you're going to give as a good or bad, and check what is coming out is good or bad or together. Make sure that out of this, can I identify the efficiency level of the DMU? What are with the DMU, right? Okay. Now I'm going to restrict on myself to the one area, what is known as a production possibility sets. If it is more mathematics, ignore. Identify the logic at student level. Once you understand the logic perfectly, mathematics is no way going to disturb you. The production plan of a DMU is constrained to a given production possibility set, representing essentially its limited technological knowledge. Say, for a given DMU, a production plan is a specification of the quantities of inputs and outputs. So what? Once you know the quantity of inputs and outputs, we already know what is known as a production possibility set. Mathematics and economics, we say big theory, but that's what it is already. Under the basic properties. That's what. In research, we say that we stimulate with the more properties. A given production plan may be technically possible or impossible for a given DMU. You agree or not? Yes, right? Suddenly can you say that this particular DMU is inefficient? Like take our example of a student, right? The last time the running of a student, right? The game. Take that. Then you are defining that. If this particular student can run 1 kilometer, if at all he drink 10 bottles of Coca-Cola. Possible? That's no meaning, right? You can make a student who is inefficient, you want to make him as efficient, you are giving an advice to him that make him to drink 10 bottles together and ask him to go for a 1 kilometer. It never adds any value to you. So, say that there are sometimes that what we say technically possible or impossible. The set of all production possible for a DMU is called its production possibility set, usually denoted by a matrix X and matrix Y. X may be consist of a vectors of different inputs and Y may be consist of a output vector. It's a matrix having a different vector sets. P, if input X can be produced, output Y. So let's discuss some commonly assumed properties of a production possibility set. We have already seen that. What is that? The one point which is attracted as is no free lunch. That's one of the property, right? I said that there is no free lunch. Let's say that. What is that? One is closed. It's very basic mathematics property when we start with this kind of analysis. Let P includes its boundary. What you are saying is that the data is a boundary and it's a closed set. When you say free lunch, what is free lunch now you can understand. You see that? It is impossible to produce something from nothing. You agree or not? Is it possible to produce something without anything? I must be a god to do that one. Without giving any input producing something, I must be either a great magician or a god who come from heaven to do this kind of work. But in industry, it is not practically possible to produce something without anything. Free hand. So, no free lunch. So that's a basic property. The free disposable. What is the free disposable? If you do something like that, it should not affect your cost. It should not affect your production. If it's not affecting anything to you, you can say the freely disposable. Right? Can I dispose my code freely? No. Why? It's going to? What is it going to do? I'm going to lose the money, right? Which I bought my code. But I can use a tissue paper. I can say, can I throw this one? Yeah, the tissue paper is not going to add value to me. Yes or no? Same goes here also. When you say freely disposable, the interpretation is that extra amount of inputs or output can be disposed or eliminated at no cost. At no cost. Then you can say that it is freely disposable. Otherwise, disposable is cost you. That's what I heard that in European countries actually. If you happen to vacate the house, right? You rented a house, you bought everything for the house, and you lived for 2-3 years, and then you want to leave the house. You are going to the other country. You want to dispose whatever you bought in the house, right? You have to dispose the table, chair, and everything. To dispose, you have to pay the cost. You know that? You know that? To throw your product or to move your product from your house to dustbin, you need to pay money to move that. So it is not freely disposable. It costs you to dispose. The next one is known as a convexity condition. So usually it's a terminology called convexity condition. So what this convexity condition tells us, it's more rotate around the lambda. Okay, what is this lambda essentially? The lambda is referred as an intensity variable. What is intensity variable going to do with this? This intensity variable is an indication for us which provides the peer information. Who is my peer? Right? I told you that it is not only the efficiency analysis. After the efficiency analysis, one needs to identify who are all inefficient, how to make them to move towards an efficient. Yes or no? Yes. So if you want to move, it is not like that. I can show that, hey, come on, among your friends, who is inefficient? let's say that for understanding purpose, the last fellow is an inefficient, right? There are some professors are sitting, let's say that one professor is an inefficient, but I put all together for my analysis. I made the analysis. One professor inefficient, one student inefficient. I cannot say that, come on, a student, you are inefficient, you should work like that professor. No. Because I need to tell that if you want to become an efficient, you follow the peer who is nearest to you. You should not follow a peer furthest to him. No. So this particular lambda provides me such an information to whom I should go near. Who is my nearest peer to perform, not for the furthest one. You get me? So that's what it says that this particular lambda. So this lambda is usually restricted to some 1. So what we say there? The intensity variables of lambda is restricted to 1. If the sum is restricted to 1, then we see that we are under the convexity condition. In much more terminology, what they use in DEA, when the moment they say that the convexity condition holds, then we say that we are under the variable written to scale. Otherwise, we are under the other kind of written to scale. One basic is, if you don't include this particular property in your model, you say that you are under the constant written to scale. Okay? Fine. So these are the 4 properties which comes inside. Now you see that I am doing that what is known as a mixed input and mixed output. So though I have shown that the input is x and the output is y, so what I am trying to say is the input x what you are giving can be split into 2 groups. One is good input, the other one is bad input. The bad input what I am referring is undesirable input. The bad is identically equal to the word for undesirable input. Similarly, what we can say, we can also try with an output with a desirable output, undesirable output. You get me? So you are giving a set of desirable, undesirable input to get desirable and undesirable output. With this for every DMU, and you are going to measure which one is efficient. Some of the existing approaches, whenever we deal with the undesirable outputs or inputs, let's say that to time being let's take the output, how are we going to deal with this? So what is the idea? I told you that you always need to increase your good output, right? And what you should do? You should suppose to reduce your bad output. Agree that? You get me? So okay, I want to maximize my good output, minimize my bad output. What I can do? I can just put a minus sign towards that, and I say that maximize the bad output too. You get me what I am trying to say? Just put a negative sign. If I want to reduce the function, if I want to reduce u, if I want to minimize u, can I say that minus and I can say that maximize that? Yes or no? Basic logic, right? If I want u is a bad one, undesirable. You get me? Undesirable, what I should supposed to do? I have to minimize it. But my model is I want a maximization model. So I want to add this fellow inside. How do you do it? Add a negative sign with that. And now you maximize it. What happens? Indirectly what you are saying? You are trying to minimize the model, right? This is one way. But what's the problem comes? The DA is more sensitive to the negative numbers. They try to disturb your negative numbers. So what they said that? Then they said that actually, okay, if this is more problematic, how to solve the problem? Then later stage, Zhu came out, but before that other people came out. Zhu came out and said that actually, okay, negative number is going to disturb you. Add one positive number which is largest among this set, so that everything becomes positive. And you deal with that. So they came out with the next technology of telling that minus u, add a positive number with that, and then you do it. See, this is research. People say that research is complicated. I say that research is the most simplest thing to do. It's out of my experience of 45 research papers in this age. Once you understand what is research, publication is easy. otherwise no. So here what I did, you see that it did not do very great thing. Minus u is the problem, right? Because DA is not going to accept negative information, it's going to trouble you. How to convert this negative information to other information? They said that add some largest number with that, and that's going to solve your problem. They came out with a series of publications. You see the number of publications, all are top journals. I'm telling you, it's all are top journals. Who are published? He published in EJOR, and those fellows, the pastors from the C4 also, all are from JOS, Journal of Operation Research. Very good journals they came out. But what's the techniques they used? Very simple technique. You know that this technique is not now. The technique was almost, I can say that maybe hundreds of years back. A king got a doubt. King said that, I put one small line here, and one of the minister he called, see that this is a small line. Can you make it without touching the line? It is a line. He put a line. He said, can you make anything with this line? I want to see this line to be minimized. But do not touch the line. Then he came out with a small theory that I used to tell to my daughters actually, that how to do that one. He came out with that, King, it is very simple. How? Put a largest line along with that line, then this line becomes small, automatically. So that theory only worked here. What says that? If you have negative numbers with you, then what you can say? Convert the number into positive, add appropriate positive number with that, it makes you to become positive. So they changed it. They came out with the new information. And then they said, okay, what about this? What about, why don't we invert the number? U is an undesirable output. If it is an undesirable output, why should we keep that as like that? Reverse it. So if you minimize it, if you maximize this, automatically U is getting minimized. Yes or no? Basic logic. So they came out with again a series of papers out of this. Right? Again they said that it's a research on DE. So we accepted it. I'm also doing a research on DE. Okay? So but this is a basic concept that how we play around the numbers, the basic concept, but still it gives a very meaningful information in the real life. That's what it is. Fine. So my further discussion going to be whole in this line. So I'm going to use 1 by U. Then there comes the problem. Hey, DA was a linear programming model. The moment I start use 1 by U, it's become non-linear. It's complicating you. Then they say that, come on, Taylor already proved a Taylor series long back. What Taylor series does? Taylor series try to approximate the nonlinear information into a series form, right? This is that we can start use the Taylor series methods to do this one. Okay, to start with, knowing all this basic idea, I'm going to get into my consultancy paper, which is recently published in International Journal of Production Economics. So, yes, thank you. Okay, so what I'm going to do here is measuring the efficiency of the assembled printed circuit boards with undesirable outputs as my concern, right? Output is something useful. So this is an engineering application, so you can enjoy it. This engineering students are here, you can enjoy something what exactly is going to be. The course is going to be like this: some introduction and the methodology, something known as a jackknifing. I'll tell you what exactly it is. Okay, and then efficiency of printed circuit board and potential improvement of it. Conclusion. If really you like this one, then I can extend this lecture to the next one with the two-stage model. Okay. If you say you don't like it, then I say that okay, I may go pass on to my mini course and become a good professor. One student I can do. Assembly of printed circuit boards has generated a huge amount of industrial activity over the last 4 decades. Do you know what is printed circuit boards? Ever seen? Ever heard about printed circuit boards? A motherboard, right? It's a printed circuit board, right? It's a circuit board. Even for your teleprinters and your telephone, you use a board called a printed circuit board. Or you can get the circuits have been printed already, right? And after that you mount ICs on it and all the other components on it. That's what we basically refer as a printed circuit board. PCBs are consumed as an input by 3 major industrial sectors. One is computers, telecommunications, and computer electronics. Okay, sorry, consumer electronics. Over the years, production has evolved from a labor-intensive activity to a highly automated one, characterized by steady innovations at the level of design and manufacturing process. Today's multi-layered, highly complex printed circuit boards are expected to continue the trend toward increased complexity. The increasing complexity of PCB inevitably leads to higher failure rates in assembly process. So what they are telling, all the story they are telling is, if you don't do properly, you will get more error. That's what all the story of one slide. Okay, let's see that. PCB production. Highly automated activity nowadays, innovative design and manufacturing process at all times, increased complexity. So because of this, there is a higher failure rate in the assembly process. So idea, if you get more failure, the efficiency goes down. So you want to improve your efficiency, so reduce your failure rate. So the defective PCBs, when you say that PCB is defective, it's not functioning. After a certain amount of analysis, we identify that there are three possible errors are there. It could be from manual error or a machine error or other errors. Three errors, right? So if the PCB gets at least one of this error, it's not going to function. So you have to send it for the recycling, right? You are supposed to set like that PCB again, it's not going to function. Okay. Consider as undesirable output as it has to be reprocessed. So obviously I have an output now. What is my output? One is a printed circuit board which is free from all those three errors. The other one is a printed circuit board has at least one error of this, or it can have at most three errors. Obviously what happens? Increases cost and time. Obviously if my failure rate increases, I have to send it for recycle, I have to spend on my manpower, time is getting wasted, and as well as what? If at all the company is a direct company to the customer, the direct customer company, then what happens? Automatically it loses the goodwill of the customer for non-timely delivery. Yeah, the key to successfully produce PCB is experience and known how to screen even a slight or slightest possibility of a defect. So we have to look like a bird's eye view, you know that no condor and all something like that. You keep on fly and see that from all the way from 2 km or 1 km, it can catch us exactly the food it wants. So the same way industry should supposed to put their eyes in a proper way to search and identify these errors and try to reduce these errors. Okay, so I don't want to read everything, let me put it in a very easy form. The production process of this particular printed circuit board, it goes like this. See that the company buy the raw printed circuit boards. It means that just a board which is printed but it is not mounted anything on it. Then the moment they buy this board, they start sent to the production process where they are expected to mount the IC and other chips which is required on the printed circuit board. So once it is get, and they go for a soldering process, the other process, and then finally it gets molded properly. Once it gets that one, it undergoes a testing process under the quality control department. It check, does it has any one of this error? No, then it's a good printed circuit board. If it has at least one error, no, send it back. You get me? So we have 4 outputs now. One output, the printed circuit board, which is free from these errors. Other 3 outputs, what? A printed circuit board which has machine error, manual error, and other errors, right? One by one. So these are all considered to be undesirable outputs. So these errors, the 3 errors what we discussed, has some classification. What you say, when you say it is called a machine error. It's called dry soldering or short soldering. If this is coming under, then we can call this as a machine error, automatic machine error. When it comes to the manual error, there are various possibilities in the manual error. For instance, wrong component assembled. The component is not properly wrong component. It should not assemble that particular, he assembled it. Reverse component, the components have been reversed, the IC has been reversed. So like this, spin bent, so many things criteria like this we consider. And similarly, if you go for other errors, not cleaned properly. The printed circuit board not properly distillated. It's not cleaned properly. Not mounted properly. What are the IC which you expected to mount? It's not get mounted properly. Like that, lots of criteria. So our idea here is to concentrate mainly on this part, machine, manual and other errors for the DE. But what I did is I floated another paper where I published how to reduce these errors through Six Sigma. That is different issue. How to use the same information to reduce the errors using a Six Sigma techniques. But when it comes for efficiency analysis, I restrict myself on the above level and started doing a basic efficiency analysis. Okay. Now see that if you look more mathematics, I can make it put very seriously a simple information. X raw means that input, my vector is x. When I say raw, nothing mounted on it. It's a free, plain printed circuit board. That's what my input is. So I want to make my outputs. What are my outputs? Error free. It means that no error. And what else? There is an error. That error can be classified into now 3 types, right? Machine error, manual error and other errors. You get me? So I have classified into 3 errors. Okay, that's fine. Now what is my input? Input is raw printed circuit board. Always they try to say that minimize the input and maximize the output. Here it's very clear that minimize the input. We cannot minimize the raw printed circuit board. Rather than what we should suppose to minimize the errors. Now the basic assumptions, the 2 assumptions, the basic property which I dealt early, the basic assumption what I made you see that the output are weakly disposable, right? I cannot dispose my output that much easily. And the second one, output with error and without error are null joint. It means that if you want to produce something, you end up with error. There are possibilities to get error. You cannot say that I am very great company at leading at the Six Sigma level. Then I can produce my printed circuit board with no error. No, because the manual process is involved inside. You cannot automate everything. So possibility to get error is possible. So if you produce, you get some error. It's something like a paper mill production. If you produce paper, you will emit CO2. You try to reduce the CO2. That you can say that. You cannot say that no, my company is not going to reduce CO2 at all. Or my company is not at all producing a CO2. Only papers. You cannot say like that. So that's what my second assumption says. So keeping these 2 assumptions, moving further, how to model it. So one great professor, author, this is very simple. Do not consider undesirable. Remove from your model. You just see that what is your input raw printed circuit board, how many good circuit boards you are bringing it out, and ignore your error. Don't consider your error at all in your model. Just ignore it. He came out with the methodology. That's what we say that ignoring undesirable output altogether in the DA model. Can we accept that? Can we accept that? Yes or no? Yes or no? Can we accept that? Can I ignore the output, the bad output altogether? No. Sometimes it gives a valuable information to you. Yes or no? See, consider 2 cars. Car 1, put 1 liter petrol. It takes you safely to your home. Car 2, put your 1 liter petrol. It safely takes you to the home. But sometimes brake is failure. Can we accept it? Which is undesirable to me. So we have to take it into account what is known as undesirable inside the model. So the people said that no, this is not the right way to do it. Though the model looks good, but it's missing a very good information on undesirable outputs. So when you want to design a model, when your technology involves undesirable output, better include such an undesirable output into the model where you can see effective results rather than ignoring it. So they say that, okay, ignoring what they are saying, let's see that this is a one set of input, a set of outputs. You try to maximize your output. What you are trying to maximize, you see that? You are trying to maximize error-free printed circuit boards. Trying to maximize the error-free printed circuit boards. That's what they said. But they didn't consider what is known as undesirables. So they said, no, we can go ahead with the next modeling. Testing undesirables. hyperbolic. I told you, right? So there are some way to manage this undesirable. For my early slide stated that one is if undesirable comes inside, penalize with a negative number. I say that minus u. Then I say that okay, negative number is not good for DEA because it's not functioning properly with this technology. So add a constant with that which makes it positive. And I came out to the third one. Better if you use an undesirable output, reverse it 1 by u. Now we are going to use the same. Instead of u, what I have given as an example, here it is beta. So what I said that, okay, for the good beta, for the good output, use beta. That's your efficiency value, right? For the bad one, the error one, use B inverse. What is the meaning of that? 1 by beta. So if you want to maximize your beta, what happens? Good part, you are trying to maximize this. The bad part automatically you are trying to minimize it. Simultaneously you can do this one. So that's what the idea here. So that's what the methodology says. Okay. Now let's see that this is my input constraint. This is my good output constraint where the beta is involved inside. Okay. And all the other three bad outputs tagged with 1 by beta. And there is a question comes there. What is this equality holding that? Why it should not be greater than or equal to? I already said that I am under the condition of weakly disposable set. When you are under the condition of weakly disposable set, you have to restrict your conditions here with equality condition. So that's a basic mathematics is. Okay, now the problem. Now this problem is not a linear programming. This is a non-linear programming because I am trying to maximize my parameter beta or my decision variable beta with one set of constraints with the linear. Now these three are non-linear. What I should do? Either use a good technology, good programming methodology to run a non-linear programming, or use the logic of mathematics to convert this non-linear programming into a linear programming. So here I came out with the methodology saying that this particular non-linear programming can be transformed into a linear programming. So they say that, okay, the beta max, we know that what is the maximum value. So here, whenever you talk about the efficiency, the maximum efficiency value is 1, so they are 100% efficient. The minimum efficiency value is obviously 0, no efficient, right? So the values are going to range from 0 to 1. What it does, it tries to convert this 1 by beta non-linear form using a Taylor series to a linear form. So once you did that one, the problem becomes very simple. So what it is 1 by beta, so called as beta inverse, can be reversed into 2 minus beta. He said that 1 minus beta, so 1 by beta is equivalent to 2 minus beta provided the beta ranges from 0 to 1 using a basic Taylor series transformation. So once that's done, the non-linear constraint now transformed into linear constraints. That's where. So once this getting transformed into linear constraint, then it is possible to see my model as in the place of 1 by beta, I replace that into 2 minus beta. You get me? So I am under the condition of linear programming. So what it is, for the student level, you can run simplex program. That's it. So otherwise, you have to think of running a non-linear programming methods, right? And then you have, there's the Gunteker condition, sufficiency condition, we don't need to worry about. A simple Taylor series helps us to transform this. So we are not going into the Gunteker level. We are going to restrict ourselves to a very simplex method. Hence, the model now converted from a non-linear constraint to a linear constraints. You get me? That's what it is. Now if I solve this problem as a linear programming problem, I can get what is your beta. But hold on. It is not just like a linear programming. Linear programming, you solve the problem only once. In data envelopment analysis, we solve the problem n times, means n DMUs. In the first example, when I consider 5 students, I have to solve the linear programming 5 times. For which student I am solving the model matters to me. So if at all I want to identify him as my first DMU, I have to solve the model for him. What does mean that? The him, what I am referring is his input, his output. And here, all the 5 students input, output. You get me? So compare with all the 5 students with the student which I am interested. Banking sector, compare all the banking sector as a as a combination like this with a particular bank. So if the Peru consists of some 20 banks, let's say that, then obviously you have to run this model for 20 times. For one bank, one time. Now, considering this one, the linear approximation form of hyperbolic output efficiency measure is defined as this, and the model is very simple. You get me? I want to maximize my beta subject to this technology, which is known as a, we refer now, production possibility set. Okay. Now what we say that, obviously when you want to solve the problem, hope your professor would have taught this one, include slack information inside, right? The slack variable, surplus variable. Did you study something about surplus variable? Slack variables? I'm not going to ask any questions. Study it or not? In simplex method. Surplus, slack, right? So those informations have been brought inside for a particular purpose. The purpose, what it says is actually, if you want to identify, okay, you are saying that efficient, two students are efficient, but are they equally efficient or not? That's a condition. Sometimes you say, no, efficient, but one is weakly efficient, another one is strongly efficient. You get me? Among the efficient student itself, you can classify it. So here also the same condition comes here. What we can do is, we can classify efficient, strongly efficient, and weakly efficient, or efficient and weakly efficient. When you want to say the DMU is efficient, then your beta is 1 and the slack variables, the S whatever you are dealing, all are zeros. If all become zeros, it means that you have used whatever given as an input, you have clearly used everything, but you gave a perfect result as 1, then you can say that it's efficient and S is 0. If you want to say, no, my beta value is 1, but something is there with me, S values are there, some slacks are there with me, then you can say that, yeah, still you are efficient, but I can say that weakly efficient. You get me? So when S is having some value in it, so when S is greater than or equal to 0, strictly greater than 0, and beta is 1, you call that as a weakly efficient. If not, you call that as a strongly efficient. You got me? So usually we never use a word called strongly efficient in DEA, we say that efficient. Weakly efficient, and S got some numbers in it. Otherwise it's will vanish. Okay. So considering this particular logic, then whatever I'm talking is there actually. So I can say that the model can be viewed in this way. So this usually the DEA process we call this, the DEA is on a two-stage process. The process 1, we try to maximize it, and the process 2, what are the value which are achieved, we pull that value into the process 2 value, the beta max. It means I know what is my beta and try to derive what is my S. If I get an S, then it's an indication for me it's a weak efficient. Otherwise, not. Okay. Now, this is the model. Now come to the application, right? The model is ready with me. Then how am I going to apply this model to my real life problem? The data choice of inputs and output variables is more important. How many input you are considering, how many output you are considering, how many DM you are considering, always proceed. You must know that the basic thumb rules behind this. This is because DE is sensitive to variable selection. If variable selection is not correct, DEA results are not robust enough. As the number of variables increases, what is the meaning of that? As the number of variables increases, if you increase the inputs, if you increase the outputs, if you more increase, then you cannot differentiate between the good and bad. Good DMU and bad DMU. I am not talking about good output and bad output. You cannot discriminate between the efficient DMUs and inefficient DMUs. Everything looks like a same. Differentiate because you cannot discriminate. I can put it the right way. You cannot discriminate among the DMUs if the number of inputs and output get increased. Okay. The more variables are added, the greater becomes the chance that the sum of the inefficient unit dominates in the added dimension and becomes an efficient. This is another problem. What's the problem? It's also a logical question. You see the logical idea. You see that I have only 4 or 5 students in my class. I can easily identify who is efficient, who is inefficient, right? If I have the total auditorium is filled with my students, very difficult task for me to identify who is efficient, who is inefficient, who is a culprit, who is playing with me when I am teaching, who is seriously attending. Same thing here. Same thing, nothing more than that. You see that? More number of variables added, the greater becomes the chance an inefficient student looks like to me efficient student. How? Nicely sitting in front of the computer, right, and seeing the Facebook, right? So what happens is actually, maybe student will be looking very efficient to me according to my eyesight, but what he is actually, he is an inefficient student. I can identify such an inefficient student after the examination only, right? So here also D also says that do not increase the number of variables, concentrate on that. Thus, to preserve the discriminatory power of DEA, the number of inputs and outputs are kept at reasonable level. When you are selecting your number of inputs and number of output, reasonable level. That is the reason I did not consider the errors which I have shown. Remember that under machine errors I have shown 2, manual error 4, 5, 6, other errors 3. I did not consider all those things into my model. What I did, I grouped it and got machine error, manual error and other error. Why? This is the reason. If I have considered all the defects inside, then I may not be getting a perfect results. You get me? Okay. In our case, 35 out of 38 cards. The cards what I am referring is a printed circuit boards. 35 out of 38 cards are processed in one of the 4 assembly units of the teleprinter company. This particular company has 4 departments. Okay. So the 38 cards are prepared or produced in 4 different departments. Some of the cards may move from one department to the other department to get it finalized. Some of the cards can be completed in the one department itself. So that's an idea here. The rest of the 3 cards are processed in more than one assembly unit. It means that it can move from one assembly unit to the other one to get it produced to get a final phase. Whatever it may be, I consider every department as a unique department. Means even a printed circuit board moving from one department to the other department, when it moves to the next department, I consider that is for second department, not for the first department. Individually valued it. So as such, I have 43 cards with me. Let's say that this is what my information. So what this information tells to me, you see that seriously. So this is the name of the printed circuit boards, and this is the overall efficiency, and this is the unit-wide efficiency. What it means. So what I did is, I took all these 43 printed circuit boards and ran one analysis of data environment analysis. Okay, then I get the results. And then I took a unit-wise information. It means that in assembly unit 1, I took how many printed circuit board, I ran the analysis. I want to check that is there any matching taking place or not. So if I run this analysis with the 43 printed circuit board, this is my efficiency. If I run this with the 21 printed circuit board, this is my efficiency. You get me? Oneness, it's something like this, no? It's very simple, you can understand this logic very easily. One is checking the efficiency of the student, engineering student, industrial engineering students, mechanical engineering students, civil engineering students, individually from the department. Other one, considering all the students as one group, finding an efficiency. Same thing I did it. Overall, I consider all the cards which is produced by the industry, by the company, consider as a DMUs, so 43 DMUs, one go. The other one is every 1 unit. Now what happens, you see that this is for my second unit, this is for the third unit. Carefully observe what is happening here. All are become one, right? But is it one here? Just see that when I am referring overall, it's not all one. But when I am referring individual, all one. Why? That's all the logic behind the mathematics. What I said that with the number of variables increases, there are every possibility that inefficient unit become an efficient unit. That's what the statement I gave. When I analyze the overall, that's fine. When I come to here, how many DMs I have? Hardly I have 8 DMs with me. But what is my input? 1 input. How many output? 4 output. Altogether 5. The very thumb rule says that at least 3 times that level. So 5 into 3, I must have 15 DMUs to run my model. But what I did, in that particular department, I have only 8 cards, so I run with 8 cards. So I was not in a position to discriminate my DMUs in the individual department. But whereas when it comes to the overall department, I may be I'm in a position to differentiate, but not here. That's what the default. You cannot do anything. Okay, this is a basic statistical test. I made it. Let's get into what is exactly the tackling field. After doing this information, so we need to check that whether our model is good or not. Whether is it robust enough or not. So what is the meaning of the robustness? So it makes sense to me. You see that? Okay, I ranked these 4 students in my class. 1, 2, 3, 4 ranks. I gave it actually. Okay. I pulled my first rank student out from my model. What should happen? Obviously, my second rank student should be 1, 2, 3. You get me? If it happens, then I can say that my ranking is correct ranking. After removing my first student, the ranking changed among themselves. No, my model is not a robust model because removing one information is altering my ranks. Not good. So the same way what we do in JAG exactly we do the same thing. Exactly. What I do is among the efficient unit, if I remove one efficient unit from my model, does my or whether the other DMU is going to get affected or not. It's still sustaining with its efficiency level or it's altering. You get me? You got my point? The removal of one DMU, according to my example, one student from my model should not affect their rank order. Here my understanding should not affect their efficiency level. If it is not affecting, my model is robust enough. If it is not, the model provided by this particular example is not robust. So what to do? So I am trying to say that, see that all these fellows, all my students are holding my DA model. If I remove one fellow, you get me? My model should not get affected. That's what I should say. Okay. So what does it mean? I have a 5 efficient DMU with me. Remember that there are 2 ways one can do it. One is efficient, inefficient put together and removing only efficient or inefficient. Other way around, much more efficiently, considering only the efficiency DMUs in the model and removing one DMU like this, my model should not affect. You get me? My model should not affect. If my model affects, it's not robust. Do you accept any construct? Civil engineers are here. Civil engineers, do you accept the model? If one of the pillars is removed from the building, building is going to get collapsed? No. Right? Same goes to the mathematical model also. Removing one efficient DMU, this model is going to get shaken. It does not consider to be an efficient model. Okay. So to do that, what we'll do? We take the total results from the model. Okay. And then I take only efficient units. What are the efficient units? And I try to remove one by one. My 5 is my efficient unit. 7 is efficient. I remove 5 and run the model. What's happening? 7, run the model. And then 11, run the model. It's a complicated model. You need to write a program for this. Then I can identify. After removing like that, does my correlation affect or not? Is there any problem with my relation between the original model and the removed model? Removed at one at a time. First I have to check it. Okay, that's fine. And then what I am going to check? Check the mean technical efficiency. Mean efficiency. Whether removing of 1 and 1 does affect. So without removing, my test value is 0.7713 is my average efficiency. And removing 1 by 1, does it going to affect? Okay, I removed 1, 5. What I got? 0.766. I removed 7. I got my efficiency as 0.7964. So keep on removing 1, I got it. Now I go ahead with the basic statistics. Test, is there any difference exists between the model where an efficient DMU removed from it and then without removal? My p-value says very clearly that there is no significant difference exists between the model which is existing and the model which is removed with the efficient values. Fine. So I am robust. My model is robust. So it is required in the research paper. When we submit a paper to the journal, these kind of things, they say that how I can accept your model is a robust model. And when we do the robust model, then they say that okay, it's fine. Okay, fine. The next one is what? I have analyzed something with the mean technical efficiency, and then I said the correlation. This is another correlation, another known as a Kendall's tau B. It's a much more strict sense of a correlation. Then here you see that something is excess is coming here, which is known as non-efficient DMUs. Okay, apart from this analysis, what I said, if I remove the model, is it happening any one of the inefficient unit becoming efficient or not? Sometimes happens, right? Because your friend is doing well in the class. The moment he left to another university, the fellow who is not doing become good because no other fellow is there to perform in the classroom. Same thing happens here. So we analyze that, is there any other inefficient unit is prompting to be an efficient unit? Not much. As well as new DM is the reference set. So this is another concept. Initially I told you that what is the primary concept. The idea is not only identifying the efficiency unit in the model, but also the inefficient unit should supposed to become an efficient. If at all you want to make an inefficient unit to be an efficient, you need to find a friend for them, right? A friend for the inefficient unit. The friend of the inefficient unit in DMU, we refer to as a peers. So usually you get few peers where the inefficient can become a friendship with that to become or to move from inefficient position to the efficient position. What we check is, when we remove any one of the efficient unit from the model, does this friends group changes or not? The peers changes or not? So we check that. So new DMUs in the reference set. The reference set is the group where I can tell you that if 7 is removed, do we get a new friends inside? That's what. So most of the time it should be nil. Then you can say that it is robust. Keep on the model is changing, it is not robust. The same test carried out for the other set also. Okay, this is quite interesting actually. What is this actually? Initially we did an efficiency analysis. Now we go to the inefficient analysis. We say that okay, classify the inefficiency into some groups. Okay, what we learned in statistics, quartiles concept. I use the same quartile concept. I have used the 3 quartile concept, quartile 1, quartile 2, quartile 3, based on the given efficiency. I classify that highly inefficient, fit for nothing, right? Marginally inefficient, every chances for marginally inefficient become efficient. So we can start trying for this information. Okay, if this fellow, let's say that number 1, which is inefficient marginally, wants to become an efficient one, where it should go? It should supposed to match with the 5, 7, 16, 21. Those are the friends for them. Who are friends for the number 1? These are the cards are friends for the number 1. If the number 1 wants to become an efficient, he should follow whom? He should follow these cards. And he said that you don't need to worry about the input, but he should supposed to increase the output to 30%. If number 1 wants to become an efficient, what he should do? He should increase his good output to 30% more. And not only that, it's saying that it should reduce its error level 30% less for machine error, manual error and other error. If this particular PCB does that one, then I can say that he is going to become a friend of this efficient group. He becomes efficient unit. So this is what the analysis is. So one is identifying the inefficient and how to make that to be efficient. So all the statistics provides you that information. How much I should reduce my error. How much I should increase my good output. Okay. And doing all the gimmick actually, see, once the baby is ready, then we put a powder on it. Make up it, right? Comb it properly. That's the thing what we do in the research paper also. Once this is done, we try to provide all the information, additional information in the statistics. See here, the statistics what it provides here is the 7. 7 is considered to be then more friendly for most of the DMUs. And next goes to 26. 43, he is efficient. 43 printed circuit board is an efficient one, but it is not more closer to any one of the existing printed circuit boards. And similarly, that's for the overall unit. This is for the 2 department units, assembly unit 1 and assembly unit 2, we did it actually. So this one very clear. So it says very clearly that here you see that in assembly unit 2, we have 3, 22, 26 and 33. These are the 3 DMUs who is efficient and who is also a member of other groups. Okay, the future direction. how I can bring this research to the future direction. The future direction is very clear. I have analyzed the department individually, right? Now what I'm going to do is I'm going to analyze the department in future. Okay, already I did the paper on it. So the future, something like this. Department 1, input comes, output goes. Some input, some output of department 1 may become an input to the department 2. So output has become input. Then there will be some other input is coming inside. Then you will be getting some outputs from department 2. It's not going to stop. If undesirable, you need to repair the printer circuit board in this department. Once it's produced back, it should go to the department 1. Department 2 produces again, goes again. Then, or else some second, third. If this particular model, which I already solved and published, if this particular model is done, then it can be a better model than the existing model. Okay. So with this, I am concluding that the total model, how to analyze it, right? So whatever I said is under the conclusion. Okay. Due to the time fraction, we are exceed of our time. I should suppose to complete my lecture with this. If you have any other queries, very short question, maybe 1 minute you can raise the query now, or else offline. Because the time is getting ready for the next course. Do you have any clarification required? The lecture was okay. You got some point, más o menos, some extent. Okay, can I have any questions? This 1, 2 from student side or professor side? Okay, in a month's time you will be getting this particular paper what I presented here in International Journal of Production Economics. It will be online by in a month's time. It's ready for, already a galaxy proofreading of this paper is done. You can read the paper if you want. Or if you like to read the paper much more well in advance, kindly send a mail to me and forward the paper to you. If there is any more questions, let me complete my lecture here. Thanks for calling me for giving this plenary talk. Thanks a lot, one and all.